All right, so let's look at the Triangle Inequality Theorem. Can we make triangles with the following length of sides? So we're looking at maybe 3 centimeter, 4 centimeter, and 5 centimeter. Or how about the triangle 3 centimeter, 4 centimeter, and 10 centimeter? Or maybe a triangle that's 3 centimeters by 6 centimeters. And so let's look at each of these three things and then explore kind of what happens there. So I'll just start out by constructing those lengths of sides. So we'll start with the 3, 4, 5. So I'm going to do a given length segment. We'll just start with the big one. That one's 5, and then we'll put one that's 4, and from this other side we'll put one that's 3 centimeters in length. Okay, and then let's manipulate them. So now I just have to drag these around and form a triangle out of them. And it looks like here we're not going to have any problems whatsoever doing this. There we go. So we've got a nice triangle out of that. Looks like and it's a 3, 4, 5 right triangle, if you know the rule. And so that one easily makes a triangle. Okay, so let's take a look at the next example. So let me just let me just get rid of that, and we'll put in the next one. And the next one was 3, 4, 10. So again, we'll start with the 10. So this one will be 10 centimeters, which goes off the page a little bit. Oops. We'll move that. Oh yeah, there we go. Got it to fit. And then we need a 3 and a 4 off of there. So we'll do a 4. And then off of this side we'll do a 3. Might have to move it over just a tad bit so that we can bring that around. So we'll bring that around. And you might already see that we're having an issue, because my 10, okay, so here's my 10, this bottom one. Here's my 4, and here's my 3. So there is no way, without stretching these lines out, which you can't, then they'd be a different length, there's no way we can make a triangle out of a 3, 4, and a 10. All right? So how about 3, 3, 6? So, and if you look at that, the reason that is if this is 10 and this is 3 and this is 4, I mean, these add up to 7. They have to add up to at least 10 in order to meet. All right, so let's look at one that does add up exactly. So let's look at that 3, 3, 6. Does that make a triangle? So 3 centimeters, 3 centimeters, 6 centimeters. I mean, think to yourself, does it? Can I make a triangle out of a 3, 3, 6? Okay, so again, I'll just kind of fly through and get rid of some of these. Okay, and here we go. So 6, we'll start with the big one. Put the 3 here, and the other 3 over here. And start swinging things around. And then here's the other 3. We'll bring this down. Oh, hey, it looks like they're going to meet. It looks like we can make a triangle out of it. Because even if it's a skinny triangle, oh, looks like we made a triangle. But if you zoom in, notice they haven't hit yet. They're getting close. Maybe if we got really close to the line, we could make a triangle. Looks like they hit again. Okay, so let's bring it down. Let's zoom in and see. Did they hit? No, there's still a separation. And what you'll notice, I gotta zoom way out. What you'll notice is that they actually only meet when the two lines are on top of the, I can't even grab the other one. There we go. Now, if we zoom in, we'll see, well, I haven't even got it to hit the line yet. And you'll see that if I can zoom in far enough, again, there's separation there. These do not meet. You can even see it more. So, not until we hit that line exactly, precisely, do they meet, which doesn't form a triangle. So if we zoom out so we can just see our line, there's our 6 centimeter line that we began with. You can see that we've formed a straight line. We have not formed a triangle. So what's that tell us? Here's another nice little thing I got off the internet, but this kind of illustrates it pretty well. So depending on what your longest side is, so like here, this is the green one's a 4, the pink one is a 6, and the other one's an 8. So 6 plus 4 is 10, which is bigger than the big one, so we're okay. But the minute we get this down here, so like here, this is a 4, 6, 2. Well, now 6 is our biggest side. Yeah, and so your 4 and 2 add up to 6. So you've created a line with that. And you can't even, if you go smaller, it doesn't make one at all. And so you could play around with this a little bit. So here's one, 4, 4, and 7. It's got a triangle. But the minute we take that down to 4 and 3, we've got a straight line again. The two smaller ones do not add up to more than the bigger one. And so we could adjust this back and adjust this one up to 5. So 5 and 3 is more than 7. So that works. So what all this means in terms of just generally, and this isn't perfect by any means, but if you take your two sides of your triangle, so whatever they are, so say 5 and 7, if you have two sides of a triangle, say this is 5 centimeters and 7 centimeters, what would be the smallest we could make? Well, if you made the third side a 2, that makes 7 your biggest side. 5 and 2 is 7, so this is not a triangle. But if you did 2.1, now 5 plus 2.1 is 7.1, which is bigger than your biggest side, so this is now a triangle. So we know that the third side would have to be bigger than 2. I'll call x the third side. It has to be bigger than 2. And how big can we make it? Well, if you went to, let's say, 12, 5 plus 7 is 12. Now this is your biggest side. If we went any bigger than that, let's say we went to 13, now 5 and 7 is less than 13, and 5 and 7 is equal to 12. So neither one of these would make a triangle of any kind. So we'd have to work clear down to something less than 12. So you could go 11.9. 5 plus 7 is 12, which is more than 11.9. So that is a triangle. So any length. So if I started with 5 and 7 as the lengths of my triangles, then my third side could be any number between 2 and 12. So 3 would be great. 8 would be fabulous. But you can't go below 2 or 2, and you can't go above 12 or 12. And so your third side, your two smaller sides have to add up to more than your largest side. And to me, that's generally what it is, without all of the mathematical symbols and notation that go with it. Just what is it? Bare bones. That's what it is. So I hope this helps you understand triangle inequality theorem.